Okay, on your note sheet, we're doing power functions and function operations. Think back to, yes, Algebra 1, when you first learned function notation. Okay, first examples. Addition. Here's my f of x function. And here's my g of x function. It says to add these two together. What paper? No, I stopped it. I never had time to read the paper, so I stopped delivering it. Create a new function, the h of x, by adding the f of x, which is 2x, and we're going to add it to the g of x, which is x plus 1. And then we simplify it. You want to sit behind the printer? Okay, so I can combine like terms. Plus 1. There's my new h of x. Yeah, you know what? You might have Abruzzo still. Do you have her note packet? Do you have her note packet? X is 3x plus 1. What's my domain? What kind of function do I have here? What's the domain for any polynomial? Any polynomial that we've done or we're going to do in this course? What's domain? Boy, you guys are losers. Half of you on your cell phones losing, and then the other one. Oh, wait, I never call my students losers. Negative infinity to positive infinity. Shh. Okay, let's do subtraction. Quiet, 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 quiet. What's your language? Quiet, quiet. This is in your note packet. That's your practice worksheet. We've been doing this for over a semester now. You know how it works. We take notes. We take notes in our note packet, and then the practice worksheet you pick up every day, and you do your homework on that. Homework. Understand? Okay, subtraction. Shh, 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 shh. The f of x is 2x. I'm subtracting my g of x. Now, please use parentheses when we're doing subtraction. Quiet. Subtracting x plus 1. Because if you don't use parentheses, you're going to forget to distribute the minus side. So I get 2x minus x plus, or minus 1, almost did it myself. 2x minus x is 1x minus 1. So that's my new h of x, which is f of x minus g of x. What's my domain? Thank you. Now we multiply. I'm going to multiply my f of x, which is 2x. And I'm going to multiply it to my g of x, which is x plus 1. I still have to distribute 2x squared. And distribute 2x times 1. 2x. This is a function. What kind of function is this? You're close. It's quadratic. It's a parabola. And then the last one, division. I'm going to take my f of x, which is 2x, and I'm going to divide it by the g of x, which is x plus 1. By the way, is that a function? No. Okay, shh. This is not. What do I have to watch for in this particular? Hey! Hey! Quiet. All right, my domain here is not going. My domain is not going to be. My domain is not negative infinity to positive infinity. Because, Sam, because something's going to happen in my denominator if I choose one number. What's going to happen? Kayla. What's going to happen if I choose a particular number in my denominator? In a fraction, what can I not divide by? 0. Okay. There is one number here that's going to make this 0. X plus 1 cannot equal 0 because it will be undefined at that point. Subtract 1 from both sides. What number is not going to work? X cannot equal negative 1. That's my domain. All numbers except negative 1. If you put just x cannot equal negative 1, you're good to go. Okay, ready to put some numbers to this? Okay. All right, f of x is 2x cubed. G of x, negative 6x squared. We're going to add these two. So the f of x is 2x cubed plus the g of x is negative 6x squared. We should simplify these. I get 2x cubed minus 6x squared. Easy, right? Subtract. F of x is 2x cubed. Subtract the g of x, which is negative 6x squared. Simplify it. 2x cubed plus 6x squared. My answer. Okay, they want us to switch the order. So we're going to do g of x first, which is negative 6x squared, plus the f of x, which is 2x cubed. Put it in standard form. 2x cubed minus 6x squared. Hey, look at that. These two are the same. And D, g of x, negative 6x squared, subtract the f of x, which is 2x cubed, simplify it, I have negative 2x cubed minus 6x squared. All right, number 3. F of x is 3x. The g of x is x to the quarter. So the f of x equals 3x. I'm going to multiply to the g of x, which is x to the 1/4. What is 3x times x to the 1/4? What do I do to the exponents when I have the same base multiplying? So I have x to the first plus 1/4, which is, that's right, 5/4. Was it?
I think so.
What? Yes. And letter J. You know what? Let's do let's do 4L. No, because I don't want to divide fractions. It'll take me all day. Maybe. It'll be on your practice sheet. Yes, you do. All right. Geez, stop your whining. Okay, the f of x is 3x over x to the 1/4. When I have division between variables with exponents, what do I do with the exponents? That's right, subtract. 1 minus 1/4 gives me x to the 3/4. Right? 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 Any domain restrictions? What can x not equal here? Zero. Yeah, just x cannot equal 0. Can I what? When I have the same base, when I multiply with the same base, I add the exponents. So don't forget, if there's no exponent there, it's a 1. No, again, shh, guys, quiet. When I have the same base, I have x. I'm multiplying with the same base. I'm going to add the exponents. That's the rule. Now, if I had x times x, that's what you're thinking of. I'm actually adding the exponents. 1 plus 1 is x squared. Yes, except for 0. Oh, I. Well, with multiplication, we can have 0. Well, 0 is a number. We just can't have 0 in the denominator of a fraction. Okay, so x, 0 to any powers can be 0. Yeah, but you can have anything here. It's multiplication. I told you that twice. I just didn't write it down. Stop! Let's try something a little harder. Let's do. Oh, we better do number 5. All right, composition of functions. Composition of functions. Now, here's my f of x. Here's my g of x. Now, this is the new fancy way of writing composition functions. Okay, the old way is this old way here. This is the way I grew up and was taught. This says the f of g of 2. This says the f of g of 2. It's the same thing, but just written differently. To me, this is more complicated. When my nephew asked me for helping in his math class, and he says, can you help him with composition functions? And he gives me this. I'm like, I can't do that. My brain does this because I did thousands and millions of these. Okay? I think it's easier to do it the old way. But don't, if you go on in math, if you go on in math, you're probably going to run into this. And they actually use that open circle that means composition. They actually say it as like fog, goff, foff, gog. I mean, they actually say that. I use f of g of 2 in this case. Okay, so what this means is you're going to start in the middle, innermost parentheses. It's just like a regular PEMDAS problem. Hey. Okay, so I'm going to start with what's in the innermost parentheses. So I need to find the g of 2. The g of 2 means that wherever there's an x, I'm going to put a 2. So I have 2 times that, 2. I screwed it up. So I'm going to put my 2 minus 1. 2 times 2 is 4 minus 1. So the g of 2 equals 3. I am doing the g of 2. Does everybody see that? These are really complicated, guys. Okay. So, shh. You better take some notes. The g of 2 is 3. So instead of putting the f of g of 2, I'm going to put the f of 3 because that's what the g of 2 is. With me? Okay. So I have the f of 3. Well, I look at the f function, and wherever there's an x, I put in 3. So the f of 3 is 9. And that's the answer for the f of g of 2. 9. Okay? Let's do the next one. This time they tell us, well, start with the f of 3. So the f of 3, we already did, but I'll do it again. I'm going to plug in 3 for my x, which is 9. So the f of 3 is 9. So instead of the f of 3, I'm going to plug in 9. So I have g of 9. So I'm going to look at my g function. And again, wherever there's an x, I'm going to plug in 9. So I have 2 times my x, which is 9, minus 1. 2 times 9 is 18 minus 1. So the g of f of 3, or GOF 3, is 17. Okay, they want us to do FOF, negative 2, or the f of negative 2. So I have to find the f of negative 2. The f of negative 2, 3 times negative 2 is negative 6. So I'm going to replace the f of negative 2 with negative 6. So I need to find the f of negative 6, which equals 3. And I'm going to substitute in negative 6 for x, which equals negative 18. We all hate YouTube. That's language. All right, D, GOG of negative 4, or the g of negative 4. So we need to find the g of negative 4. The g of negative 4 equals, I'm going to plug in negative 4 wherever I see an x. So I have 2 times negative 4 minus 1, which equals negative 8 minus 1. So the g of negative 4 equals negative 9. Instead of the g of negative 4, I'm going to plug in negative 9. Okay, I have 2 times negative 9 minus 1, which equals negative 18 minus 1, which equals negative 19. Okay. Like I said, these get really, really complicated. What is today, Wednesday? I don't think so. I don't think we're going to have enough time. Yeah. Sabrina? I've tried different. The only way you're going to get this down packed is just to practice the problems. It's going to take a while, but it will come to you. We're going to take tomorrow and just do the whole worksheet in class tomorrow. Okay, I might even get another worksheet, get some practice. Yes, Alana? Yeah, I'll put this video on. It is very confusing. When you get into composite functions, it gets bad. Yeah. It's just going to take some practice. Might as well keep doing some more practice, and we'll just do the worksheet in class tomorrow. Oh, your brain hurts? Okay, you can stop. I don't care. That's good enough.